Hey, welcome to my YouTube channel. This is part 4 video on Keytool. In today's video, I'll talk to you about Java security providers. I think it's necessary for you to know what they are and what they do. I'll start with an introduction on Java security provider, followed by a demo which includes configuring a security provider. Let's roll. So, what's a Java security provider? In layman's term, a Java security provider provides services that you can utilize to enhance the security of your Java-based application. Therefore, the name Java security provider. In technical terms, these are cryptographic engines that a Java app may use for a variety of crypto operations. The operations supported by these providers are known as services. They may implement an algorithm such as SHA, AES, or RSA. They may also implement various crypto operations such as sign, verify, or encrypt, decrypt. They may also have their own keystore implementation. Some providers even allows a Java app to talk to a smart card or a hardware security module. Now, based on your use case, you could decide on which provider suits best for you. Do you want to use some basic crypto operations? Use SunJCE. Do you want your app to talk to a hardware security module? Well, use SunPKCS11. Do you want some enhanced features like ASN1 encoding? Use Bouncy Castle. I'm going to log into my Linux virtual machine now and show you how these providers work. Alright, for today's video, I have prepared 2 Java codes which I will be using for this demo. I've provided a link in the description below for my GitHub page. If you want to view or download these codes, you could just head over to my GitHub page and you should be able to find them. You should also be able to find all the Keytool commands that I executed in the previous video as well as in this video. Let's have a look at these 2 Java codes. So listproviders.java is supposed to give me a list of all providers that are available on this machine, and list services is supposed to give me a list of all services offered by those providers. So I'm going to compile and execute this code. So java c listproviders.java. By the way, if you want to know the version of Java that I'm using, this is the version. Right, I'll clear the screen. Java list providers. So these are the list of all Java providers that are currently available on this machine. Similarly, if I execute Java C list services, and let me clear the screen, Java list services, and obviously have to mention the name of the provider that I want to look up. These are all services that are provided by Sun provider. If I want, I can change the name of the provider. So if I mention SunJCE, these are the list of all services provided by SunJCE. If I'm looking for something specific, I would just use grep, and for example, I want to get the list of all ciphers, and these are the list of all ciphers that are available with SunJCE. Similarly, if I want to get the list of all key generators, these are all key generators that are available with SunJCE. How about keystore? I'm sure you're already familiar with this name, JCKS. So JCKS keystore is a part of SunJCE. Let's change this provider to SunJSSE. I'm sure you remember this name as well, PKCS12. So PKCS12 keystore is a part of SunJSSE. And what do we have for our Sun provider? Our Sun provider has JKS and DKS and then case exact JKS. We have already used JKS in our previous video. Now that brings us to our next question. Where is Java getting all these providers from? Well, you see, in Java, there is a file called java.security, which has a list of all providers. This file can be found inside gre lib security directory of your Java home. So on my computer, my Java home is inside opt java jdk gre lib. One second, let me add cd to it, and security. Inside this directory, here's the file, java.security. Let's have a look at this file and see what's in it. Scroll down a little bit, and here it is. Now these are the list of providers that are currently configured with Java. Actually, these are the providers that comes pre-configured with Java. It's like out of the box setup for Java. So here we have the Sun provider, we have Sun RSA sign, Sun EC, and then we have Sun JCE, and we also have some other providers. I'm sure by now you must have noticed that these providers are placed in an order. So at number 1 we have the Sun provider, at number 2 we have Sun RSA, and all the way down to the 9th place we have Sun PCSC provider. Now this is the order in which Java would search through these providers for a service. Let's take an example of JCEKS keystore. So if I were to use a JCEKS keystore using Keytool, Java would automatically search through this list. So it will first check if Sun provider provides JCEKS keystore. The answer is no. It will look at the second one, the third one, the fourth one. Finally, it will look at the 5th provider, which is Sun JCE, and we know for sure that Sun JCEKS or JCEKS keystore is a part of Sun JCE provider. So it will immediately start using this provider and continue with whatever operation we want using Keytool. I'm going to open another terminal, and one second, let me bring this over here. This one here. Okay, if you have noticed, the order in which we see this list is the same order we have our providers configured over here. So let me exit out of this. I would have to sudo it. So sudo nano java.security. All right. Now, if I want, I can change the order of these providers. For example, at number 5, we have Sun JCE. And let's say, for example, I want this provider to be at number, let's say, number 3. So I can simply, oops. Sorry about that. Okay, I'm going to comment this line and paste this provider here, and of course I have to change the number. So number 3, number 4, number 5. This line is already commented. So if I put a hash, that is considered a comment. Okay, so 6, 7, 8, and 9. I'm going to save the changes. Let's run this code once again. Now you can see over here, Sun JCE is appearing 3rd in the list. You need to be careful not to break this order. The list of providers should be in proper order. Let me show you what would happen if you break this order. So at the moment we have 1, 2, 3, 4, 5, and this one is commented, 6, 7, 8, 9, and everything works well. Let's say, for example, I change, okay, this 5 to 6. Now there is no number 5 The line that we have here, this is commented, so it's not number 5 or the 5th provider. So there is no 5th provider in this list. It's just 1, 2, 3, 4. I'm going to save this file and let me run this program again. Check this out. 1, 2, 3, 4. Only the first 4 providers were loaded. It did not find the 5th order, and that's where Java stopped searching for other providers. Let me correct this. If you want, you can do something like this. For example, I can change this to 1 and change this to 9. Okay. So at number 1, we have this, number 2, number 3, number 4, number 5. So it does not matter how you write this list. You just have to make sure that the order is not broken in any way. So let me save this list and let me run this program again. As you can see here, Sun PCSC version 1.8 is appearing first in the list, and Sun version 1.8 is appearing last in the list. Although this line or this entry is first in the list, but the number it has is number 9. So that's why it's appearing 9th in the list. I have now put everything back to the way it was. I will now show you how to configure another security provider in Java. There are 2 ways in which you can load a Java security provider. First is static. This is what you see here. So when you want to load a security provider statically, you mention the entry of that provider here in java.security, and that way Java knows what provider to load. Another way to do it is known as dynamic. In dynamic loading, you don't have to write anything into java.security. Provider is loaded dynamically by passing information about it at runtime. I'll start with statically configuring a security provider. For this demo, I'll be using Bouncy Castle. So to do that, it's quite easy. I'm going to add another line. So security.provider.10 org.bouncycastle.provider.bouncycastle provider. Save the changes. You also need to download the Bouncy Castle provider from their website. I will leave a link in the description below. Or you know what? I'm going to open a window and I'll show you what I mean. Bouncy Castle. Here's the website. If you're going to Java Home, you should be able to download the Bouncy Castle from here. So the latest release as of 31st March 2022 is 1.71. If you click over here, you should be able to download the jar files that you need. All right. For this exercise, I have already downloaded the required files. So I'll just copy those files into jre-lib.ext. So this is my Java home, and I'm going to copy those jar files into jre-lib.ext. I already have them in the home directory. Of course, it's going to ask for the password. Okay, let me change the permission as well. So sudo chmod, it's 644 asterisk. Okay, very good. Let's run list provider. And there you have it. BC 1.71. Let me show you what would happen if I don't copy these files. So I've already copied it. I'm just going to delete it and I'll show you what happens. Okay. Files are deleted. And we don't see Bouncy Castle. So it is important. Your java.security should have that entry, and your ext directory should have the jar file that has the definition or information about that library. I'm going to bring those two files back. So sudo cp home Bouncy Castle bc prov asterisk. Okay, and chmod 644. Okay, very good. Let's run this program again. And I see my Bouncy Castle provider. And that's how you configure a static provider. Now that we have our Bouncy Castle provider configured, let's try to generate or create a Bouncy Castle key store. So keytool -genkey -alias my signing key -key alg rsa -key size 2048 key store. I'll just name it mystore.bks, store type bks, and I'll just pass the dname as well. Test, hit enter, password, confirm password, and that's it. And we have our Bouncy Castle key store. Let's do Keytool list on it. Keytool list -key store mystore.bks, store type bks, password, and there it is. Key store type bks and key store provider is BC. Keytool was able to find Bouncy Castle because we added an entry in java.security. We also copied Bouncy Castle libraries into grelib.ext directory. I will now delete those two files and remove the Bouncy Castle entry from java.security. So sudo rm bc prov asterisk and security. I have to sudo it. Nano java.security. Bouncy Castle. Here's Bouncy Castle. I'll just comment it. Save. All right, let me run this keytool list command again. All right, it says java.security key store exception bks not found. We are getting this error obviously because we removed the Bouncy Castle entry from java.security. Also, the Bouncy Castle library does not exist in the ext directory because we deleted them. In some situations, you may not be able to make changes to java.security file or copy libraries into grelib.ext. This may happen because you can't elevate your access, or you don't have admin privilege, or you can't like sudo it. For example, if I do long listing on my opt java directory, you can clearly see that it is owned by root, and I cannot go ahead and directly make changes to it. I have to sudo it. But what if I don't have a sudo access? Like what if I'm not a sudoer? In such situation, you can load Java provider dynamically at runtime. This helps a normal user who can't make changes in Java home to use whatever provider they want. For example, over here, let me clear the screen and I'm going to run this command again. As you can see here, it shows an error that says bcast not found. All I need to do to load a provider dynamically is add these two lines. So provider name, you know what, I'm going to close this and I'll expand this window. Okay, so same command, I'm just going to add dash provider class org.bouncycastle.jce.provider.bouncycastle provider and provider path, it's in my home directory, software Bouncy Castle. This is the file that I want. Now if I hit enter, it's asking for the password, which already looks good. And there it is. It is using Bouncy Castle and I can see the contents of my key store. And this is how you load a provider dynamically at runtime. Thank you very much for watching today's video. Today we learned about Java security providers, what they are and what they do. We learned how to load a provider statically and dynamically. We also learned how to configure Bouncy Castle provider in Java. I hope you found this video to be informative. Please leave a comment in the comment section if you have any question. I'll be happy to answer them. Subscribe to my channel if you're not already subscribed, and I'll hopefully see you in my next video very soon.